All right, so we have my favorite SGH people on the podcast today, and we're going to focus on the new energy code because I think the audience is primarily from around the country and not accustomed to what has come to Boston. And honestly, I kind of um, think it's very comparable to Local Law 97 that we've had, which hasn't really been implemented. The key target was in 2024, and then it really becomes stringent in 2030. But the other one is bird-friendly glazing in New York, where it suddenly hit us. Everybody was kind of pushing it off, and then it came by surprise, and nobody knew what to do. And that's what I sort of feel like is happening at the moment in Boston. There's a little bit of a panic in a. I know you guys work on a good blend of new construction and existing buildings, but it feels like there's a big question mark and unknown in the market. So I think to start, it would be good for you guys to talk a little bit about, I guess, how long you've seen this coming, and if maybe you guys are not as surprised as the rest of the market is.
Yeah, I can answer that. I guess I would say we weren't surprised, but I will say with this newest update to the stretch code, it's probably the biggest change to the stretch code with the least amount of concurrency time. So kind of from when it was released to implementation has been, a big change for everyone involved. I think if you look at the trends of kind of the last 4 years or so, you can kind of see the writing on the wall, like pre-2020, where you were in a world where you would just run an energy model for your project. People more or less didn't think too much about the facade performance in terms of energy code compliance. And then after 2020, there were some kind of small changes to the code where they started implementing backstops and other ways that you wouldn't just rely on an energy model. But this is kind of the big one where there's been a lot of changes in terms of having backstops and, taking into account thermal bridging your facade. And so it's really requiring, I would say, facade designers and manufacturers and architects to really think hard about how they're designing their facade and be really careful with the detailing in a way that we had always recommended before, but, it wasn't necessarily code required.
What is the code, this most recent version modeling? Is it a mirroring rather? Was there some precedent set in a different city, or did they look at maybe some of the codes in Seattle and New York or even in Canada and sort of look at what's worked and what hasn't? Where did all of this kind of stem from?
Well, I would say we've seen, so just to take a step back, in Massachusetts, we have kind of the base energy code. And then what we're talking about here is more the stretch energy code, which can be adopted by jurisdictions. It's adopted by probably, 90% of the state at this point. So it's essentially our base energy code. But we've seen it in other states and other areas. I would say the newest iteration of this stretch code is based on a lot of the principles that you see in Passive House with reducing air leakage. So that's a big piece of it is, have to whole building air leakage test to show that you've reduced your air leakage. It's based around, improved U factors, so better thermal performance, just kind of a lot of the aspects of Passive House, I would say.
Yeah, and Adrian, I would add, I think, as you alluded to in New York City, you have this stepped implementation that you're working through, and that's brought on some familiarity with the ideas of the linear derating that people are starting to look at and starting to understand. With us, they looked at that and they said, yeah, we should just do that. And it was boom, like instantaneous. So there was no learning curve or time to bring people up to speed in terms of how much of an impact the linear derating has on an overall facade. And some of my architect clients are still a little bit in shock and disbelief when we run a model on even new construction where they're, having to significantly increase, the exterior insulation thickness, or in other areas, they're having to just rethink about the design to remove, some elements that they want to use to break up the design, because each one of those breaks ends up being a thermal path and starts to just negatively impact those calculations. So
are we talking completely different systems and completely different means of utilizing different assemblies with lower window to wall ratios, or is it just paying closer attention to detail around thermal bridging around the window opening or penetrations within the system for anchorage or whatever it might be?
I think you're going to see modifications to systems the way we used to see them, right? Like, as an example, a typical unitized curtain wall system with just a couple inches of insulation probably isn't going to cut it. What we're seeing more of is trying to find ways to introduce more insulation into curtain wall systems, whether it's kind of pushing, if you had like a rain screen cladding glazed into the curtain wall, pushing some insulation outboard of your mullions, whether it's looking at options for interior insulation. I think we're getting creative with existing systems. Also just in terms of our thermal breaks, kind of changing and modifying thermal breaks in systems. So I think we're going to see a lot more of that, but I do think there's going to be changes just inherently to the way we design buildings. I think, in general, if you have a ton of glass in a building, like a big unitized facade, you're gonna have to think really carefully about what systems you use, what type of glass you use, just kind of how that all works, right? And what U factors that achieves. It may not work sometimes depending on the exact design of the building. So we're seeing more of a push to talk kind of earlier on in the design phase during schematic design, conceptual design, just to talk about what is this building actually going to look like? What's going to be your window wall ratio? What systems are you thinking? Is this achievable? The other interesting thing we've seen is with the new stretch code in Massachusetts, part of the way you classify your building and look at it in terms of the performance it needs to receive is, or to achieve, is based on the percent glazed wall system it is, which is essentially, how much curtain wall you have in your building. If you're in a situation where if you're less than 50% glazed wall assembly, you have to achieve a certain U factor. If you're more than 50%, you have to achieve a different U factor. The one above 50% is a little bit more lenient because they recognize it's a little bit harder to hit that when you have more glazed systems. I think when you're right on that cusp of that 50% line, we're going to be looking really closely about where you want to land in terms of your percent glazed wall system, right? Because if you're 49%, but you have to achieve a more stringent U factor, that can be more challenging too. So there's a little bit of nuance in terms of what systems we're using and kind of what the overall building is achieving as well.
As Mary's talking about the U factor in the both the low glaze and high glaze, this is the UA. So it's the overall U factor of all the above grade vertical wall systems. So it's taking into account not just your curtain wall and your fenestrations, but also your opaque wall assemblies. And that's where sometimes we can really get challenged because the equations also sort of try to steer you away from doing spandrel in your curtain wall assemblies because they measure spandrels as if they're an opaque wall assembly. So there's some real challenges in looking at 100% curtain wall assembly if you want to have spandrels to break up that design.
For a lot of this feels like it's interpretation of the code, and in terms of level of enforcement, who is out there enforcing and who's validating if you truly meet code or not, and something that's measurable like a blower door test or a whole building blower door test or air infiltration testing. That's something you can look at a piece of paper or test lab and verify. But the true as-built thermal performance from a U factor standpoint is challenging. So I guess before we get into that, who's involved in writing the code and influencing it and making it so that it can be easily legible or digestible by any architect or any builder?
Yeah, I'm not sure I'd call the code easily digestible ever, but but I do think sometimes it's easier to read than other times. So one of the main entities that's been involved in writing the stretch code, particularly in Massachusetts, is DOER, which is Department of Energy and Resources. And I know that they've had advisory committees from some consultants in the industry and whatnot. So I'm not sure exactly where this newest standard originated from, like how it kind of arose, but I think it did. You could kind of see the writing on the wall over the last 4 years or so of how facades have generally become more stringent. And so I think this is kind of the natural progression of, for a while we were trading off everything and making really efficient mechanical systems, but not worrying as much about facades. Then we worked into kind of, well, we're going to focus on our facades more. Now we're kind of like, let's hyper focus on our facades to make sure they're performing well. I think also part of it is driven just by the climate initiatives and sustainability initiatives in Massachusetts in particular. There's some other specific local requirements related to energy use of buildings, and we're really trying to make sure that we limit our fossil fuel use in Massachusetts. So that's another big piece to this new stretch code, is trying to limit our energy use. But yeah,
I ask because I mean, I know SGH in New York was involved in the previous energy code revision, and they go through meetings and through all of it, even the fire code and anything relating to the facade, because ultimately some type of envelope specialist has to be involved or chiming in. How can you expect DOE or somebody to understand all the little implications and how it's going to, I mean, you're able to then educate all of your clients, but there's only so many of you and you only have so much time. And there's a lot of buildings that need to be rehabbed or built.
Well, and this goes back to Mary's earlier comment about the lack of the concurrency period that we're seeing here right now, right? So while the code was being written, there were a few drafts that were put out for public comment, right? And I know of a couple that we saw in 2022. So the energy code came into effect on July 1st of 2023. That's when it took effect. In 2022 was when we really started to see draft language that was presented and posted for public comment. And at that point in time, many of our colleagues at SGH and others throughout the industry provided feedback and comments to the DOER and the whole committee that was assembling the code. So there was this period and this attempt to try to clean up the language during the writing phase, but it's challenging when you're just writing until you have those actual project use cases where you get something and you're looking at it now and you're saying, okay, well, is this window a window or is it a glazed wall system? And you start to dive in, and now we know there is a difference between what is a fixed window fenestration within the energy code and glazed wall systems, which glazed wall systems are clearly defined as systems of a combination of both vision and spandrel glass. And they're given their own U factor targets within the energy code, and fixed windows and operable windows have their own U factor targets as well. So we're starting to try to digest all of these different pieces, but when you're going through the writing, until you actually have, a test case, that's where the challenges happen. And that's where the concurrency periods, in the past have really benefited. And I think New York is seeing some of that in the way in which they have the staggered approach to implementing their new laws, because it's starting to bring up the awareness of, oh, when we derate like this, we have to really increase this or change this detail. And we're now just doing it at warp speed, essentially. So
I guess, I don't know how often you talk to the New York office, but the norm here is still double glazing. And the norm in Boston especially new, feels like it's triple glazing. And so there has to be some major delta in either the U factor targets or the interpretation of the code for that to have been the sort of the byproduct.
Yeah, it's the U factor targets, I would say. I think so there's this new classification of a glazed wall assembly, which, as Matt said, is essentially vision and spandrel. And there's a requirement for U factors for the vision portion of that assembly to meet a U factor of 0.25 total assembly. And so that 0.25, I'm sure you know this from your practice, Adrian, is pretty hard to hit for a lot of aluminum window systems. I would say by and large, the trend we're seeing is if you want to use aluminum curtain wall or aluminum windows, you're likely looking at triple glazing to hit that 0.25. With different materials like fiberglass or other products that are less conductive, you may not need to use triple glazing. The other piece is you could look at other glazing products that might get similar U factors to triple glazing, like vacuum insulated glazing and things like that. But by and large, what we're seeing is the use of triple glazing.
And so a lot of this too, also, I mean, I heard you say a lot of passive house principles. Can a lot of what's been done in Europe start being adopted here? Building practices and trends, really? I mean, that feels like a lot of the recent discussions have been American versus European systems. And it's like, what? But in reality, it seems like they are, even though they're sort of what feels like 15, 20 years ahead of us. Seems like we're trending in that direction sooner rather than later.
Yeah, I think I saw a video you posted of like a 4-inch thermal break or something this morning, but
Yeah.
from the European window system. Yeah, I would say that's likely what's going to happen, right? Is we're going to start seeing more. So we're seeing this in like the glazing market, right? For a million years, we used aluminum spacers in our glass. Now you pretty much only see warm edge spacers, whereas those were normal in Europe for quite a while before they came here, right? So I think we're going to see the same thing here. We're going to see a development of new technology. So new curtain wall systems that utilize maybe bigger thermal breaks or non-metal materials. You know, we're certainly seeing that with some manufacturers using kind of composite materials and as the mullion stem to achieve better U factors. So I think that's what we're going to see. I guess I'm curious, you on the manufacturer side, like, were you aware of the code coming down the pipeline and were you surprised by it?
No, I think because we're in New York and having been hit with some recent codes that have really, it's forced us to think about thinking about what's coming and where you want to compete and where you don't. And I think in New England, you've seen some manufacturers back out and focus elsewhere because they said this is just not worth it. Our product line isn't competitive or doesn't give any value proposition. But think about, you know, when I'm in Nashville, they say it's only recently that we started including argon in the cavity for a double glazed unit. And you laugh, but there's just not that requirement there. And then you go to Florida, and the first question always is your system hurricane rated or impact rated? So it's like Boston, the first question is, can you meet our energy code? Florida, the first question is, do you meet missile impact rating? And it's like everything past that has diminishing returns. So when you find manufacturers competing or participating in all these markets, that's where it gets interesting. But do you think well, before I go in this direction, I am curious, what is more challenging at the moment, taking on an existing building or a new construction project?
Existing building, hands down. I don't know if you agree, Matt, but that's my opinion.
Yeah, absolutely. I mean, one of the big things we have right now in our market is there's still a large desire for lab space and conversion of some of our underutilized office space into lab space. And now section C505 within the existing buildings chapter of the Energy Code has been modified by the Massachusetts amendments to state that basically any change of use that results in an increase of energy use of a space triggers a full envelope upgrade to meet new code. So
wow.
we are still working through kind of really digesting that with everybody that's involved, because we've got a number of these office spaces that are underutilized that are only, you know, they were renovated 10 years ago when new windows were put in. So
you're saying if you put in new heating or cooling system or a new roof, it triggers an upgrade to everything?
So it's specifically a change of use that results in increased energy usage. So there is some nuance there, and we're starting to see more like concept level energy modeling to say, is this change of use going to be an increased energy use or not? Because it could trigger millions of dollars of additional scope on a project that, you know, a lot of people wouldn't, you know, plan for. So that's where I'd say the existing building has been like a whoa, how do we do this?
Well, and I'd say it's also, so with a new construction project, you're in the driver's seat, right? You can make decisions on what geometry you want to use and what size product you're going to use, what type of products. Like you can largely make those decisions, right? With an existing building, you have a lot of set parameters. Even with like a simple window replacement, you've got whatever the size of that roof opening is, right? So you're limited to the sizes of those windows. Same thing with like if you're working on a facade. There's so part of the new code is that there were some pretty big changes to the existing building portion of the code that essentially, you know, triggers you to meet the prescriptive new code requirements if you're working on an alteration or change of use, like Matt said. And so you can imagine that requires you to take into account thermal bridging on an existing building. And so if I'm looking at an old kind of 1960s building with exposed concrete spandrel beams that we have all over Boston, you're looking at how do I improve that thermally, right? And so are you overcladding it? Are you insulating from the inside? Like it's really challenging to meet a lot of those requirements. And
So are you suddenly disincentivizing owners to upgrading their buildings if it becomes so challenging and cost prohibitive?
I think that's a discussion we're having right now, is how do we meet these increased targets with existing building stock? Because I think as an industry, I think we can all agree that the greenest building is the one you already own, right? Rather than building a new building. And we don't want to see existing buildings sit empty while we're building new buildings. And so I think there is some discussion, to Matt's point, I think we're all learning a lot from last July, basically. I think there's some discussion about what this might mean for existing buildings and how we might need to think a little bit more carefully about that, particularly because, we have quite a bit of sustainability initiatives here in the Boston area. We don't want to be throwing out, 10-year-old panels on a building to upgrade it. So we want to think carefully about what we're doing, So it's a big discussion.
Yeah, no, I mean, I know there are no concrete, this is a very gray area, but it's, you think about, like, I always try to understand, especially when we're looking at a project or talking to an owner, it's like, what's really triggering this envelope upgrade? Is it to the point where you have catastrophic leaks? Is there a structural failure? Can you not get a new tenant to move in unless you have to upgrade for that reason? There's usually some underlying motive for the owner to want to upgrade. But where do you get to the point where you just code-wise have diminishing returns and just
and
becomes
the challenge,
prohibitive?
Adrian, is if you think about kind of just the natural cycle of like when buildings are improved, right? You kind of have that 20-30 year cycle when a building starts to become a little bit more tired, and it might change hands and a new owner wants to come and freshen it up and really make it shine. And some of those, honestly, we're now seeing are more in the 50-year-old range in Boston, just because of the amount of building stock that we have. And in that, we're looking at that transitional masonry period, right? Where you have a block backup wall and a brick veneer, no insulation. And it's like, that's got some challenges that you need to work through, right? And to Mary's point, then you throw a exposed spandrel beam in there too, just for fun, to really give you some kicks.
And I guess I'll say, like, so we're dealing with this on quite a few projects right now, where we're just looking at what are the requirements and what are we doing on the project, right? And I think we've been talking to DOER quite a bit about some of the challenges we're seeing at existing buildings. I think everyone can agree we all want to see buildings be better, right? We want to decrease energy usage across buildings. We want to improve our overall, reduce our overall air leakage in buildings. Like, that's clear. But it's becoming pretty challenging with a lot of existing buildings. So it's something we're thinking a little bit harder about with this new code change.
I ask because we're seeing a lot of the, especially conversion work from office to housing, just given our housing shortage and underutilization of office space post-COVID. And that's happening left and right in a city like New York City. Is there a need for that in Boston? And then again, does it become energy code prohibitive?
There's a need. Yeah, we're seeing it too. Yeah, I mean, so we're seeing, like, for example, a lot of malls that are underutilized, right? And so they're turning department stores into laboratory space. We were seeing that for a little bit. And I think, we're starting to see a little bit of what you guys are seeing in New York as well. I think it does put owners in a challenging place if they are thinking that they're going to have to, make huge upgrades to a building that they weren't planning on originally. And so I think that's something we want to think carefully about and talk closely with the code officials about on how do we approach this, right? And I think in some situations it may make perfect sense. Maybe there's a straightforward way to improve a building, to over insulate and replace windows. Like, maybe those are maintenance needs anyways. Sometimes it's not as straightforward, like, Matt was saying before, with a building that's not quite old. You've got systems that maybe haven't been in place that long. I think those are situations that are a lot more challenging as well. One thing that we are seeing that's kind of interesting, I don't know if you've seen this in New York at all, but is one of the new code paths. So there's a couple different code paths you can follow for new design. one of which is to follow Passive House. And it's actually, if you're in a certain community that's adopted a specialized opt-in code, it's actually required for residential buildings over a certain size. And so what's interesting is the new code has, so many requirements for thermal derating, backstop, whole building air leakage testing, increased U factors, all that stuff. We're actually seeing quite a few projects go towards Passive House. And what's interesting is even some existing buildings are looking at, going towards Passive House certification. Wow. Because that's, an option under the new code as well. And
well,
sometimes
the question becomes, is it a matter of, I think I've seen Passive House in the past, people weigh out and then they're like, it's cost prohibitive. But are you basically saying they're designing to the Passive House standard and rating anyway, so let's just do the testing and verification at the end and then be able to deem this building and express, the upgrades and level of attention and care we put towards the design and execution?
Yeah, I mean, if you think about it, we're trying to reduce thermal bridges, we're trying to reduce air leakage, we're having really stringent U factors. Like, you're almost there towards Passive House in some cases, right? So yeah, I would say certainly in a lot of projects, that's something we're thinking about is, do we approach it from that aspect instead of kind of the more performance-based approach that is the alternate option?
I think I had this discussion recently. I was in a 40-something story high-rise curtain wall building, and I went to open, it was a zero sightline awning, and you couldn't even open it because of the wind. It was just not the most user-friendly. And then when I got it open, it slammed shut. So there was no friction arm or anything holding it open. And I was talking to an industry veteran that probably doesn't want to be named. And he said, well, think about by the time you get to the 40th floor, your GC is probably under a lot of pressure to wrap the building in. You probably don't have as much oversight or inspection, or it's just, it gets to the point where the quality, when you're getting towards that finish line, just starts to diminish. It's kind of like the hoist run leave outs. A lot of people are like, oh, we'll deal with it later, but that's always the most problematic area. What's interesting with Passive House is like, you have to have oversight throughout. There's no shortcuts. So it's like the ultimate means of accountability for the team.
Yeah, and I would say even with just the new code, even if you're not following Passive House, I mean, there's a requirement for a whole building air leakage test for new construction. And actually there's air leakage requirements for existing buildings now too. But I think knowing that you have to pass that whole building air leakage test and submit a report at the end is a big deal and a big discussion that's going on during design and pre-construction, right? Like, because essentially you've got so many different trades that have to own this if there's something wrong. And that test is often being completed kind of towards the end of construction after the building's pretty much done, right? So we're having a lot of discussions early on about, okay, I'll just use like an easy example. We have always recommended that, when you have a fastener going through your air barrier, you should seal it for both water and air leakage. There's many projects where people push back and say, we don't want to do that because of cost or time or whatever, right? That's something that, sometimes was removed from projects. Now I would say many projects, they're saying, well, we've got this big whole building air leakage test. Do we really want to risk it? And so there's discussions about things, just, that's a minor thing, but I think it's a big discussion early on for teams.
And the other thing, Mary, and I haven't seen this firsthand yet, but I've heard about it, and a couple of the projects that I'm on that we have a CM on early that they are talking about it, is the CMs essentially are assigning a superintendent to be solely their whole responsibility on the job site is to monitor the air barrier and the air barrier detailing going on. That's all they're doing. So they are spending, their full days making sure that the details are being addressed. The RFIs are going into the design team for complicated, transitions or details. And when they're installed, the technicians in the field are installing them the way in which they were designed, because they just, nobody wants to have one of these situations where the air leakage test goes bad and then they're trying to search and hunt down and solve those problems. So
I feel like if that precedent is set early on, there's something kind of nice about, instead of like the angry facade consultant coming in with, the binocular and calling everything out. It's like, no, we all don't want to see this happen. So whatever it is, a weekly check-in, we all know what we're looking for and what we're working towards. And when I did a lot of inspection work, that was a lot of, I think, the point of contention. At least if you explain to the glazers or installers why you're looking at what you're looking at. They just look at it as following a set of instructions or whatever they're being told to do. But if they understand this is the objective, and if we don't do this, this is what we're going to deal with down the line, I would think it creates a little bit of a different dynamic.
Yeah, I agree. And I think, ultimately, I think the big trend we're seeing is that we're bringing on stakeholders a lot early on in projects, right? So even just for U factors and performance, we're bringing on glazing manufacturers and installers much early on during the design phase. And I think we're having these discussions early on so that it's clear to everyone what the challenge, like what the considerations are and why we're thinking about these things so hard. And that allows, GCs and CMs to really plan ahead and think about that during construction. And to your point, Adrian, like they understand why they're looking at every little piece of the air barrier to make sure it works, right? Because no one wants to be back there after the building's complete looking for air leaks.
Mm-hmm. So in a little bit of a different direction, I want to ask Matt this one because of his architecture background. What has been the response or feedback from the architectural community from a design standpoint in terms of implementation of new systems, or like I said, more opaque area, or just the change in requirements and how they need to rethink the way they envision buildings?
Yeah, I think, I don't think we have the full picture yet, honestly. But this has been something that I've been thinking about, that it's going to be really interesting to see over the next few years how the skyline, changes, because you can look back and you can see the trends, right, through history. And, for the last 15, 20 years, the ideas of the glass and metal panel buildings, that was what we saw, because using unitized systems was efficient. You don't have the issues with staging, et cetera. And so that's where you see a lot of the design that's happened over the last 10 to 15 years on the higher buildings. I think we are going to see a lot more opaque wall assembly get brought back into the equation. And, this might transition into the use of more kind of like mega panels and things like that, where there's a balance of glazing and opaque wall. But I haven't heard, I haven't heard any like real negative, oh, this is making it so I can't do a design that I really wanted to do. I think with all of this, generally at this point in time, the architectural community tends to be pretty positive, and it's just a challenge to, it's another kind of driver that they have to consider when they're putting together their designs. So it's not I think maybe there might be some developers that want a building to look a certain way, that then when they talk to their architects, like, well, that's going to be a real challenge for us to do. So, but we can do this, which might be kind of like what you were saying. So I think that's where we're going to see, a lot more opaque wall than we have in the last 10 to 15 years.
When you were first saying that, I was thinking to what Matt Bronski was talking about, where there's this bank that he drives past, and certain portions of the facade had window replacement during certain eras. And you could almost, he's a historic preservationist, so he probably looks at these buildings and there's a whole story going on in his head. But based on what the trends were, materiality or whatever was driving the design community, tells the story of what that era was.
Well, and that's, you can see that even, if you look at the last 40 years, right? In the 90s, we still had a ton of masonry buildings going up. And that's cavity wall construction was how we built things in Boston. And that was, partially because of, Boston is a fairly traditional city and we like our red brick, and they wanted to hang on to those red brick buildings. But we didn't have kind of the crunches in labor until we got to that kind of 2010, 2015. We started to see the real crunches in labor. Labor costs start to get more expensive, and then going to something unitized like the curtain wall, where you have less labor and it goes together quicker, starts to, be reflected. So you can chase those kind of, aesthetic things to other things throughout the city. And this energy code is going to be no different. It's definitely going to have impacts on the way in which, this era of buildings look throughout the city.
Have you been in any of these passive house projects? Do you notice a difference in terms of they always say occupant comfort, and think people have a hard time wrapping their head around that until you experience it. I live in a pre-war building. It has replaced windows, but you're against that drywall or sheetrock against the uninsulated masonry wall. It's cold, and I have to pump the heat. And it's like you have to feel it or see it to get it. But I haven't been in one, but I'm told when you're in a passive house building and you have the tight compression seal with the operable windows, or you have the appropriate glazing, and the sound in an urban environment is tempered, it really makes a difference.
Yeah, I think we were talking about this, a little while back, that I think you were asking us, Adrian, are backstops effective, and like putting these U factors in place, are they effective? And something Matt and I were talking about is that, in some buildings for so long, the mechanical systems drove the energy performance, right? Just because like in a lab building, it's going to take up so much of your energy use. But where having improved U factors and improved insulating values is really helpful is in that occupant comfort, right? Because like you're going to have improved surface temperatures, you're going to have, a lot less air leakage through the building. Like that's all going to be so helpful to occupants, particularly in, apartments, residential living situations.
This is a little bit of a strange question, but can the building become so airtight that it's all of a sudden you're shooting yourself in the foot? Like, do you want to elicit some means of natural ventilation? And do you think at some point you see more automated facades where you're going to have the windows opening and closing based on time of year, time of day?
So, this is a complex question, right?
Yeah, that's why I was weary of asking it. But I mean, you push to more airtight, and it's like, okay, wait a second, we took this too far.
So, if we break it down to just the idea of can you be too airtight, the simple answer is yes, if you don't have active ventilation, right? And that's so, you go back to the 70s and the energy crisis. That's when you see the first kind of thought process of tightening up buildings. And then that's when sick building syndrome came around, and people were literally getting sick because the buildings were too tight, but they didn't have ventilation. That's when, a lot of those standards came into play to make sure that we were getting the right amount of air changes for the right occupancy levels, and understanding that our buildings are getting tighter, so we need to make sure we have this. So we now have that pretty well dialed in, and we understand how to make sure that we have ventilation, but most of that is done through active ventilation, and they're using heat exchangers and other things. So it's done efficiently, but now there are conversations within the design industry of looking at the ideas of now making it a passive system, and using passive ventilation instead of this, mechanized mechanical. That adds just a whole another layer, because how are you, it's, I think, much more difficult to measure the passive systems than it is when you have the active systems, which, how many CFM, that equipment's going to be moving for your space. You can do those calculations. I haven't talked a whole lot with the mechanical engineers that I talk with about the ideas of passive ventilation to see how they're feeling about it. But I know there's a few, communities that are pushing it pretty hard.
It feels like we're a little overwhelmed and proactively reacting and making the best decisions as possible. Although in 10 years or 20 years or 30 years, we might look back and say, how are we doing that? Why were we not using this material? How was air tightness or triple glazing, or we've been the glazing pocket, whatever, not the practice for every single building. Do you think ultimately, though, it's allowing us or forcing us to head in the right direction, and Boston is really setting a precedent for the rest of the country?
Definitely. Yeah. I think Matt and I were talking about how this reminds us a lot of when NFPA became the big thing on the street, right? Like it was like, everyone was like, how are we ever going to meet this? How are we going to have NFPA compliant assemblies in our walls? And it was like this panic, but everyone adjusted, everyone figured it out, right? Manufacturers adjusted their systems. They learned how to test, like we figured out the products to use. I think it's going to be similar now, right? There's people who are concerned and who are like, oh my God, how am I going to design my building? How am I going to renovate my building? But in the end, I think it's achievable, right? We can make these things work, and we just have to figure out what are the right systems, how are we going to implement them on our project, and the design team has to be really thoughtful about that. But I think it's a good thing. It's a good thing for Boston. It's a good thing for the country to be moving towards better, greener buildings.
That's all I got for you guys. Well,
All
this
right.
was fun. Thank you for hopping on. And I truly think that both of you are, I respect that you guys you come across like you are subject matter experts in facades and the energy code, but also saying, look, we don't have all the answers and we're just trying to figure it out and implement the best facades as possible. So I respect that, and I like that about you guys. And it's challenging, but it's fun what's happening in Boston, because I think, like I said, it's going to be a precedent for the rest of the country, and it's only a matter of time that these exercises start bleeding elsewhere.
Yeah, I completely agree. I think it's an interesting time to be in the industry, but it's a lot of fun.
Yeah. And it definitely is. And yeah, I feel like with the this code especially, I feel like I get my arms wrapped around like one part of it, and then I turn the page and there's another little variable
Surprise.
or curveball that I didn't quite see coming that changes my whole thinking on that last part that I thought that I had understood. So
Keeps us on our toes.
it's continually evolving, but I think the next year especially we're going to get a lot more of these projects honestly through the permitting process and these discussions, or then we're going to have precedents that we can look to. The challenge right now is we just don't have any precedents to look to say that this is how we went through this particular scenario.
Yeah.
So
All right. Well, thank you both for hopping on. It was a lot of fun.
Thanks for
absolutely,
having us.
thank you for having us.